Rain begins with a mystery. Have you ever wondered how can these clouds hold so much water? Let's find out. Welcome to Simply Wonder.
Simply wonder.
If you step outside on a freezing winter day and breathe out, your warm breath instantly turns into a visible, swirling puff of fog. That tiny, everyday phenomenon is the exact same physical process that creates the clouds we see in the sky. But there is a massive difference in scale. A single fluffy cumulus cloud can actually weigh thousands of pounds. This raises a question. If clouds are carrying thousands of pounds of physical water, where is it all coming from? We don't see massive rivers flowing upward into the sky. And even if the water gets up there, why does all that weight stay suspended above our heads instead of crashing down on us in a sudden flood? The sky parade above us is a massive scale version of your winter breath, governed by the unseen forces of temperature and pressure. To find the water, we have to start at the surface of the ocean. Every day, the sun's heat warms the water in our lakes and seas. This heat causes the liquid molecules to spread apart and transform into an invisible gas called water vapor. This invisible vapor is constantly rising from the surface, drifting upward into the sky without us ever seeing it. But the higher that vapor travels into the atmosphere, the more the environment changes. The surrounding air gets significantly colder. Just like your warm breath hitting the winter air, this sudden drop in temperature forces the water to react. As the diagram shows, the freezing air forces those gas molecules to stop spreading and start clumping together. They crowd back into the tiny visible water droplets and ice crystals we call condensation, much like a crowd of people huddling together for warmth. The cold sky essentially reveals the ocean water that traveled upward in its invisible state. To prove that these shapes are made of real, heavy liquid, imagine jumping from a plane and falling toward a cloud. From a distance, they look like cotton, but hitting a wall of mist at 100 miles an hour is a sharp, painful experience. You are slamming into millions of freezing cold, liquid water droplets. At that speed, they feel like tiny needles striking your skin. Because these droplets are physical liquid, Earth's gravity is constantly pulling downward on every single one of them. Here, we see why they stay aloft. The gravity arrow pulls down, but is matched by upward air currents pushing back up. It works like a beach ball hovering over a powerful fan. The upward air catches the droplets and suspends them midair. Every cloud is a delicate balance between gravity pulling down and wind pushing up, keeping all that heavy water floating in the sky. So invisible vapor rises, the cold reveals it, and the wind holds it up. If that balance is so perfect, why does it ever rain? The balance inside a cloud is constantly shifting. As rising vapor clumps together, droplets bump and merge until larger, heavier drops. When they become too massive, the upward air fails to support them, and gravity finally wins. That moment where the air can no longer hold the weight is what we see on the ground as a rainstorm. The next time you look up at a clear, quiet sky, take a second look at those clouds. Those fluffy white shapes are actually massive levitating lakes of ocean water. When you understand the unseen forces of temperature and pressure, the sky becomes a massive, constant science experiment happening in real time.
Isn't nature amazing? Something as soft and fluffy as a cloud can hold millions of tiny water droplets before they fall as rain. If you enjoyed discovering this mystery, there's so much more waiting to explore. Subscribe to Simply Wonder and join us for more amazing discoveries. Until next time, keep wondering.